Hello. Welcome to the last lecture of the architectural modeling course, the rendering workshop. Creating a good photorealistic image is not just a click of a button. You have to learn to deal with light, shadows, and know the physical properties of materials. Finding the ideal viewpoint, and gradually building up a photorealistic image that reflects reality are essential steps in this workshop, where we will go through the steps of daytime outdoor rendering. Let's take a look at the finished concept to understand our goal for today's workshop. By the end of the workshop, we aim to create a render with a clear daytime sky, achieving contrasting light and shadows. Let's open the project we'll be working on. It's the same project we worked on in the previous workshops, but we've deleted some things to focus on the rendering. For example, we deleted the terrain and the neighboring buildings. In order to get a high-quality photorealistic image, we will need to make at least 25 to 30 test renders, and that will get us to the final visual design. Let's get to work. The first step is to set the perspective views. We can do this by having our 3D view active and clicking on the eye icon in the navigation bar. In the pop-up window, we can zoom in on the icon in the small floor plan, which will help us navigate through the space. We can use the blue square marker to move the camera position. Using the purple square marker, we can adjust the position of the viewing point, while the green square markers modify the viewing angle. This angle can also be manually entered on the right side. Aim for a value between 50 and 60 degrees. By holding the red square marker, I can move the position of the entire view. It's crucial that the values for both the camera and the object are at the same height. For external renders, this height is typically greater than the eye height, between 1.6 and 1.8 meter. To save the adjusted view, click on the green plus icon. Once created, double-click to rename it. Let's name this 101 Street. Okay, I accept. I want to save additional views in the project. It's advisable to save them sequentially, as if we were walking around the building. I grab the blue square marker and move it to the backyard. I'll save a view here as well. I'll do the same for the side garden. I rename them O2 Garden and O3 Side Garden. We are done saving the views. Let's see how we can navigate between the views. Either select the desired view from the list below, or use the arrows for navigation. Let's talk a bit about what factors affect render time. The first is the size of the project, which is the number of surfaces. You can see this by clicking the arrow next to the 3D hammer and selecting Build 3D command. At the bottom, you'll find the surface count, currently at 1,163,820 surfaces. A moderately powerful computer can efficiently handle up to around 1 million surfaces. If the count exceeds 2 million or 5 million, the program will send a warning. In such cases, consider replacing high-surface objects to work more efficiently and quickly. I exit and then turn off the additional layers, leaving only the architectural elements active. Let's see how this affects the surface area. I return to the floor plan, and use the layer walk to turn off the layers that are not needed, using Control key. I turn off the layers for curtain, decoration, trees, and other objects. Before I press OK, let's activate the Refresh 3D command. This way, the program will automatically refresh the 3D model, so you don't need to manually press the 3D hammer button. Let's see how this affects the surface area now. We can see that now only 16,553 surfaces are displayed. This will allow us to work much faster in the early stages. Let's discuss the factors that still affect render time. The next one is our own computer, specifically the processor speed and memory size. I can check this by typing xdiag into the computer search and running this command. Here, we can see the processor and memory information. If the system requirements are not met, it's worth upgrading our computer. The following factors affect render time: the complexity of materials and lights, and render settings. We will look into these during the workshop. The next step is to set the sun. Set the sun so that it comes from behind and never directly in front. Sun settings can be accessed through the View menu, Sun Position command. Here I can specify the city where this building is located. I choose Budapest and set the date and time precisely for when the render will be produced. I set it to September 16th, 12 p.m., and the north direction to 92 degrees. I accept with OK. Let's check how this modification affects the model. I go back to the 3D model, then in the navigation bar, I activate the Shadows command. The light-shadow contrast is immediately visible here, but the best way to see it is through a test render. We can also turn off the shadows with the switch off both option. Let's start a test render. I can start the render by clicking on the render sphere in the navbar. We can choose from various types of rendering. There's standalone and integrated rendering. Integrated rendering appears as a window within the project, just like the drawings we create. Standalone rendering runs as a standalone application, but maintains a connection with the program, accessible from a separate taskbar. Both standalone and integrated rendering have a preview mode. This means real-time rendering that maintains a live connection with the model, so any modifications to the model automatically update the render. I choose integrated rendering, preview render in real time. Let's see what additional settings we can adjust in the render dialog. The resolution and render preset also influence the render time. The higher the chosen resolution and render preset, the slower the render will be completed, but the result will be more nicer. Different sizes are available for resolution. Lower resolutions than Full HD are considered working sizes, used for test renders during the work process. Full HD and higher resolutions are used for the final render, which can be sent to the client. Additionally, user-defined resolutions can be selected if a desired resolution is not found. I am currently choosing a widescreen resolution. Let's explore the render presets. The quality of rendering is influenced by render presets. The sets generate progressively better quality and less noisy images. Each set is expected to require 3 times the rendering time of the previous one. Here, we find the preview render in real time, which, though not in final quality, produces an almost instantaneous image. Its purpose is to show a quick work in progress state. Due to its speed, this is recommended for creating work renders. Changes in the project are automatically tracked, and the image is regenerated. The disadvantage is that it may not be available on all computers. The next render preset is Q1, Quick Preview Image. This is suggested to be applied at the beginning of the rendering process. It quickly generates a work-quality image at a low resolution. This already provides significantly better results than the preview render. Next is Q2, Cleaner, Higher Quality Image. This is the next step in the rendering process, suitable for scenes approaching the final image. We recommend using it at least at medium resolution, up to 1280 by 720. If you are satisfied with the render created with the Q2 rendering set, there is no need to continue rendering with QX. However, if you are not satisfied, there is an option for QX, Custom Settings. You can see that samples per pixel and render pass count have become active. Samples per pixel is the number of ray tracing samples calculated per pixel in the image, which means it controls edge smoothing, and smooths out jaggies at the edges of objects. If we increase samples per pixel to more than 10, it will increase the render time, but we will achieve a much better result. Values higher than 10 are recommended when creating final renders, or when there are thin parallel lines in our project, such as decorative stripes, especially under complex lighting. The next value we can set is the render pass count. The rendering engine uses a progressive rendering method, refining the generated image with each step. Increasing the render pass count increases render time, but it will result in a high-quality image. The value to set here greatly depends on the type of scene. It is recommended to set a value higher than 10, if you have a complex lighting scene. For final scenes, a value of 30 is sufficient. Use lower values for quick preview renders. In the render presets, I choose Preview Render in real time. Let's proceed. The Sharper Details option reduces image noise and sharpens details. When turned on, you will immediately see the change in rendering. Let's leave this turned on for now, and the next setting is the Enable Artificial Lights. Essentially, this is a main switch that allows us to turn off all lamps, even if we left them on in the project. The scaling of the artificial lighting option modifies the intensity of the lamps. I won't make any changes here. We have various options for sunlight. This determines what external lighting affects the scene. The first is clear daylight, representing uninterrupted sunlight. The second is a cloudy daylight, where the sun's light is less dominant, resulting in less powerful light-shadow contrast than clear daylight. Artificial lighting has a stronger effect on the scene. The next option is sunset. Here, the sky becomes slightly reddish-orange, similar to sunrise or sunset. The last one is the outdoor night scene, when it's dark and we use artificial lights. For the outdoor daytime scene, I choose clear daylight. Next is the background. Here we can create different uniform or gradient backgrounds, or we can select an image or panorama. For both the image and panorama, we have the option to choose a custom background image, which can be done in the print raster option. Under the file name with path option, I browse for the desired image. From the ARCHLine.XP Draw 2023 folder, I select the image named Country Landscape and use it for rendering. The next step is to specify a folder to save render images. This is essentially a backup path, where the program creates a backup of the last state of each image created. It's advisable to choose the folder where your project is. The last setting is the background brightness, which should be adjusted according to the time of day. For daytime scenes, we recommend a value of 100, and for evening or night scenes, the lower values on the scale. I'll choose 90 for now. Before rendering, I want to show a useful feature in the program, so I accept the settings by clicking Close button. I magnify the 3D window, then select View, Rendering, Render Frame On-Off command. At this point, a gray bar appears on both the right and left sides. This indicates what will not be visible in the rendered image. Anything within the dashed line will be visible in the final image. I turn off the render frame, just as I turned it on. Let's start our first test render. Choose the Integrated Rendering, Preview Render in Real-Time command again. The settings remain the same, so I simply click the Start Rendering button to initiate the rendering. Place the render window among the other windows with the bottom left icon on the navigation bar, and wait for the render to complete. At the end of the rendering, a denoiser runs, eliminating graininess from the image, resulting in a much cleaner scene. The render image is ready. I want to achieve a much more contrasting light-shadow effect, so I'll adjust the position of the sun. I activate the 3D window, then click View, Sun, and Shadow Simulation. Using the slider, I can adjust the sun's position according to date and time. I choose August 6, 10:20 a.m. You can see that the render automatically updates, and the stronger light-shadow contrast appears immediately. With this, we can achieve a much more spatial effect. Always make sure that if there are large bright surfaces, you add other elements such as trees, plants, or for example we will also place a car here, to break up these large bright surfaces. I think the position of the sun is fine like this, so we can proceed with the first phase of rendering, focusing only on the architectural elements. I exit the preview render, and activate the 3D model. We have previously turned off the additional layers, so only the layers of architectural elements are activated. In the first phase, we will apply render styles to the appropriate surfaces. You can find the render styles on the left side at the Design Center, below the catalog. Here, we find 21 render styles for the most common material properties, such as wood, metal, parquet, glass, etc. We can apply these by using the drag and drop method onto individual surfaces. This does not change the size or texture of the materials, it only swaps out the characteristics of the materials. It is sufficient to apply the render style to one surface. If the same material appears on multiple surfaces in the project, the program will automatically change all instances of that material to the selected render style. Let's see how this looks in practice. I first apply the wall render style to the brick covering, and the white wall. The following render style is the matte one, which I applied to the paving area in front of the house, as well as to the concrete and the curb. I apply the wood render style to the partition walls. I drag it onto one wall, and it automatically applies to the others, that contain the same material. I apply the metal render style to the guttering, and the glass surfaces receive the glass render style. I would also like to show the color codes found above the render styles. You can see that each render style has a color code in the upper right corner. If we switch to color-coded display, the program shows the 3D model with these color codes, allowing us to easily check if we have applied the correct render style to a particular surface. We can revert to the original appearance with the Restore button. Let's move on to the second step, which is starting a test render. Click the Render button on the navbar and choose Integrated Rendering, not in Preview mode. I will now start the render with a Q1 render preset. I leave the other settings the same and start the rendering. This will take a bit longer than the preview render, but we will get a nicer picture. I also place this window among the others. The test render is complete, and we can observe the materials that we will need to fine-tune in the third step. What we will definitely modify is the properties of the glass. Currently, it reflects too much, almost like a mirror, so we need to adjust the reflection and transparency of the glass. If we create an external scene and get such bright surfaces, we will also need to make adjustments to those materials. I save this render, so that we can compare it with the rendering after fine-tuning. I close the render. Now, let's move on to the third step, fine-tuning. We perform fine-tuning by right-clicking on the surface we want to modify. Let's start with the glass. Right-click, Find Material. This displays on the left what material is on this surface, and the material properties are also found here. We can modify the values using the slider or manually entering them. I will change the transparency and reflection of the glass. I'll adjust transparency to 100% and reduce reflection to a minimal level, let's say 2%. I also want to modify refraction, setting it to 2.8. With this, we're done. Now, I'd like to modify the walls. Right-click and select Find Material. I want the wall to be not completely white, but a bit grayish. This way, it will be slightly darker, and I'll also adjust its brightness. Clicking on Color, I specify the new grayish color using the scale. OK, I accept. I can modify the material's brightness using Texture Albedo. If I increase the value on the scale, it becomes brighter. If I decrease it, it gets darker. Now I set it to 65. I also check that the reflection is at 3% and roughness is at 5%. These are already set, so no further adjustments are needed. I want to further adjust the darkness of the concrete, so again, I choose the Find Material command. The concrete has a matte render style, but I want it even darker, so I choose 20 for Texture Albedo. Before proceeding with more modifications and fine-tuning materials, let's run a test render to check the success of the current settings. I choose Integrated Rendering again, keeping the already set values, and start the rendering. It's immediately noticeable that the asphalt is much darker and the walls have become slightly more grayish. The render is complete. Now the glass is completely transparent. When creating external renders, and looking through the glass into the room, which is not furnished, it's a good idea to add curtains to make the space less visible. What I still want to modify is the brightness of the paving and the brick covering, as well as the brightness of the wooden partitions. I close this window, and in the third step, make further adjustments to the materials. I change the texture of the wooden partitions from 60 to 40. Next is the reflection of the guttering, as it's too reflective. Right-click, Find Material, then reduce the reflection from 40% to 20%. Now, I adjust the brightness of the paving, so I set texture to 20. Finally, I reduce the brightness of the brick covering to achieve a darker result, setting texture to 40. All the settings and fine-tuning are done. Restart a test render with the Integrated Rendering command. I create a Q1 quick preview image with widescreen resolution by clicking the Start Rendering button. I wait for the render to complete and to compare the difference between the two renders and see how it looked before fine-tuning the materials. The render is finished, and now I'm satisfied with the settings. I save the image to the test render folder and open it to compare the completed renders. Now we can see the first and second renders side by side. The difference in glass reflection as well as the brightness and darkness of the surfaces is noticeable. With these settings in place, we can proceed to the next phase, where we will focus on the accessories. To do this, I switch back the necessary layers. I go back to the floor plan, and use the layer walk to turn on the following layers: curtain, decoration, other objects and trees. I've turned these on using Control key. The Refresh 3D option is enabled, so the program automatically updates the model as I hit OK. Let's move on to the first step of the second phase. I want to create this car model and apply render styles to it. In the Design Center, I locate the render styles. Let's try out different render styles. Using the drag and drop method, let's apply the plastic render style to the paint. Drag the glass render style onto the windshield, and then let's start a test render. When dealing with accessories, furniture, or other smaller elements, it's a good idea to zoom in completely on the specific element to fill the entire screen. This helps in creating a high-quality render even at low resolution. I initiate the integrated rendering, also with a Q1 preview image in widescreen resolution. Let's see the result. It turned out very bright, so I apply a glossy covering render style, which I will then fine-tune. I close this window, activate the 3D window, and apply the glossy covering render style to the surface. I start another test render. I think this will give a much better appearance, so I'll fine-tune this. I close the render, activate the 3D view. Right-clicking on the paint, find material, then reduce its reflection to 20%. I also want to fine-tune the glass surfaces. Right-clicking, find material, I set the transparency to 100%, reflection to 75%, and refraction to 5.94. I set the blurriness of transparency to 10%, and reduce its brightness to 50, to make it slightly darker. We're done with the third step, the fine-tuning. I'll start one last test render for this car, to see if the settings are successful. I think we're done, so the paint and material settings should be good now. I close the window. Since we have completed fine-tuning the adjustments, I will now return to the originally saved O1 Street view. I initiate the next render, which will be a Q2 standalone render in full HD resolution. I click on the render sphere, and choose standalone rendering. I switch the resolution to full HD, and set the render presets to Q2 for a cleaner, higher quality image, leaving the other values unchanged. I start the rendering process. While the render is in progress, I would like to show the effects on the left side. It is advisable to start adjusting the effects when the image is not too grainy, and we can see how the specific setting will affect the image. We should always start by adjusting the exposure value and then proceed with the other values. It's recommended to make only small adjustments on each slider, and we can immediately see the changes. Exposure should be set so that the image does not overexpose anywhere. So, I make a slight adjustment to it. The next setting is brightness, which allows us to modify the intensity of the image. Again, I make tiny adjustments to avoid making the image too bright. The next is contrast, which can either highlight or darken the entire image. I now completely reset it to default. If we want to reset any slider or value to the default, we need to click twice on the icon at the beginning of the slider. Next is saturation, which can enhance or fade the colors in the image. I increase this slightly to 4. Let's move on to the next trio, which includes shadows, midtones, and highlights. These values will always affect only one aspect. Shadows brighten the dark areas. Let's see. Now I reset it to the original value. With midtones, we can lighten or darken the midtones, but I leave it at the default value. With highlights, we can darken the bright areas. I also reset this to the original setting. The last one is the white balance, where I can adjust whether I want a colder or warmer render image. Okay, I'll also reset this to the original default value. If we want to reset all sliders to default, we can use the reset all command at the bottom. The render is done, and once the denoising is applied, we can save it. If we are satisfied with the result, there's no need to proceed to the QX render. Choose the QX render only in justified cases, for example, if thin decorative strips are included in our project. Save the render by clicking the Save button. If we want to create additional renders in different resolutions or views, there is no need to exit this render window. Instead, on the right side at the top, we can switch the render resolution. At the top center, we can choose which views we still want to render, so it's worth saving different views in advance. Additionally, the program offers us additional views. Let's select the side garden view. The program immediately starts rendering. At the top, under the Details tab, we get the settings we made at the beginning of rendering. We can choose the QX render, set the pixel sampling rate, and the render pass count, and see the impact of sharper details on the project, which we see immediately. Let's stop the Q2 rendering and start the new render with these settings. If a render does not reach 50% completion, and we stop it, the program asks if we want to apply denoiser to improve image quality. If we answer yes, it runs the denoiser, and if we answer no, the rendering process stops immediately. I choose no this time. What I want to show you last is the list, next to the details. Here we see the saved views listed. If I click on a view with a green checkmark, the program will reload the already completed render, not start the rendering process again. We also have the option to set various properties for individual views. For example, I started the O3 side garden where I can set my own exposure, brightness, and other properties. In rendering details, I can render certain views with different properties. If we stop the rendering, and the rendering list becomes active, we can also choose which views to render sequentially. This allows us to work much faster and more efficiently, because I only select the views I want to render, click the Start button to start rendering, and the program starts rendering the selected views one by one. I exit this rendering window, and open the final visual designs. The one on the left was created with clear daylight, while the right one has a cloudy daylight. In the left image, the contrast between light and shadow is much stronger, which is very noticeable on the building. This brings us to the end of today's workshop, and the end of the architecture course. I hope what you saw in these videos was useful, and you'll be able to apply it in your work. Thank you very much for joining me today. Have a great day. Goodbye.